Hello and welcome. I'm Bill Wake. We're here working on a tune similarity program. We're giving it songs or tunes, and we're trying to get the program to identify which tunes are similar to each other. We've done a bunch of work. We've got some reports coming out, and we've dealt with the parsons code, which kind of captures the shape of the melody. We need to be more sophisticated now about both the parts of a song and the rhythms of a song. So the parts of a tune are the kind of high-level breakdown of it. So a fiddle tune, for example, is, at least old-time fiddle tunes, they're usually in what they call AABB format. So if you ever did analysis of poetry in high school or whatever, you probably had little line patterns like this is A, B, A, C, or that kind of thing. Music does the same thing, at least fiddle tunes do. They have parts that repeat, and AABB is just the most common. You can have AABBB, you can have ABAB repeated 3 times, all kinds of things. Okay, let's see. So I've been struggling. Xcode, I've had a break here, so Xcode is waking up slowly. Okay. Let's try again. I guess I'm off your screen, but hopefully this will come up over there. While that's going, we'll take a look at our input format. So we're doing this ABC notation. It's a specified input file. This is about 120 pages of text describing all the variations of it, and one of them is the parts. Okay, so there's in the tune header you can say P colon, and then the part structure like A B A B C D C D. Inside the tune you can mark out to say which piece of the tune is the A part of the B part. And let's see, you can use numbers. P colon A3 is equivalent to PAAA. You can put parentheses with numbers after them. You can put dots in there if you just want to, I guess, make some room. The dots are ignored. Okay. There's some interaction with variant endings. So I can define, here's the A part the first time through, here's the A part the second time through. They're similar, but they have a variant ending. And lyrics, we don't have to worry about that, I don't think. P should render complete playback. P should be printed in this score. Okay, so it's very common to put a little, like maybe a reversed white on black block with A in it, or maybe a circle A, or a bold A, or something to kind of indicate where the part is. Okay, so what we'll need to do is parse the tune header, so allowing nested parentheses, dots. So that's there. Let's go see the, well, I guess within. Okay, let's take a look at this. Variant endings, PA. Okay, yeah, so notes, then the first ending, the second ending, third ending, fourth ending. Each one of these is repeats except for the last one. All right, so in the tune body, you just say P colon and then a letter. I don't know if there's any. Let's see if we can find some definition for that. There may be, they always allow extra stuff, so I'm not surprised if they do again. Well, this is information fields. Here's that table. It's an instruction. Okay, so it's really, I'm not sure the notation, but parts, that's like AABB. In there, I think there are sections, which might be something notated like a bunch of stuff, and then oops, bracket like that, or there could be repeats and so on. And then within there, there's the common part. I guess I should indent this because that's contained. And here, there's the common parts. And then the ending variants. And these are broken up into measures, and so are these. And, well, within, maybe I should put this within measures, notes, and this one has measures and notes. And then realistically, they also contain, I don't know the right thing to call this, but maybe it's instructions. And that's what the ABC notation, just standard notation description is. But sections also have instructions. Everybody can have that. Okay. But you can have a part, it might have multiple groups of measures. The measures might just have common ones, or they might have variants, ending 1, ending 2, and so on. Within sections, you can have instructions as well as parts. Notes are within measures. Okay. Notes and ties. Ooh. Okay, so I think we're going to go from the outside. Right now we just have the notion of notes. We ignored all the measure stuff. We ignored any other instructions, and we don't worry about variants. So right now the current model is just really like a song is a bunch of notes. You can do worse, but maybe not much worse. Okay. Hi, I'm Bill Wake. We're here back working on tune similarity with the notion of working on the parts of tunes and taking advantage of those. All right. Rebooting the system seemed to help Xcode, so we'll take it from here. Okay, so let's see. We left off saying ABC parser is getting too large. Maybe that we want to look at that before we look at the parts too much. And I guess what I have in mind is that there's a lot of code here. We got 400 lines, something like that. Yeah. Well, we've pulled out some. We pulled out the note parser and the key parser. What else do we have? Well, this is the big parser. It's kind of the line parser. This is parsing notes. What's this used by? That's weird. No one's calling this. Does that seem plausible? Make sure I did this right. Okay, let's go see the key parser. Maybe we left a duplicate function. No. Well, let's just comment this out and see what happens. Oh, I did run the tests when we were rebooting. All green. Okay. Let's run them again. Maybe that was an early attempt at parsing that line. But you would think it would. Okay. I was going to say, you think it would be used somewhere in the parser. Yeah. Okay. Somehow I missed that reference. Okay. All right. Let's revert that. Parsed our keys in fine tunes. Okay. Yeah, so if you find a K line, I don't know, this thing is a bit awkward. But anyway, if you find a K line, you need to parse that line. Parser.key parser. Parser.key parser. That's not it. Where was that? Okay. Why is it not? Oh, this is parser tests. Okay, we knew that was there. Check key signature. Wait a minute. That function is only used in this test, but this is used by a bunch of tests. Find symbol. Right. Okay. Let's move that out. I mean, it's doing key parser.parse. Key parser.parse. Maybe we should be calling that directly. Let's do that. Okay, well, let's take the other approach. Let's pull this out of here. I mean, I think it's doing something useful. Key parser. Let's find key parser. I don't know. I maybe... These tests seem more like key tests. And we have the key parser. So you call make key parser, and then you can call parse on it. And make key parser doesn't need anything from anybody. Okay, so let's... The key of an input string. Let's make a key parser. So let parser equal key parser dot make... No. Dot make key parser, I think. There it is. Okay. Let's call this parse key and make that here too. And let's just make sure everybody, well, see if everybody runs still. Okay, good. Is that too awkward? I don't know. Well, that print is certainly not helpful. Okay, maybe this... We're checking the key versus what we get back. Okay, let's make a junk return and take out this print. Make sure that's okay. I think I can take this out like that. Okay, and that certainly won't match a real key name. Okay, and this can be file private. I don't know if I can fold this all in, would I be better off? Maybe so. Let's pull these two lines. Oh, this really is a result. Okay, if it totally fails, we do that. Case success. And I guess we just want value. Cannot find input in scope. Oh. I think I deleted something I needed. Okay, let's do a div. Yes, I did. Okay. Okay, input is key, k:\key name. We'll make a parser. We'll attempt to parse the input. I think I can inline that. Oh, but I needed input down here. Well, it's really key name is what it failed to parse. A little long, but I think it's clear enough. Parse it. Make a parser. Try and parse the input. Build up the expected map. This probably doesn't need to happen unless we're down here. Map each accidental. Okay. And go with that. All right. We not pushed yet, right? So this will be a nice test too for my reboot. Okay, well, it's a slow start to get where we are, but ABC parts are getting too large. I don't think that's our biggest problem at this point. I think we are ready to start doing something else. Okay. I don't think I need to do this yet. Okay, quantize parser code. Well, we're not really quite ready to do quantize. Maybe this is all towards that. I don't know. The quantize parsers code, let's see. If I, where can I run this? I guess if we let's just take no scale and here's our input file. And let's just run with that. Okay, and we generate a report. All right, now it would be nice to go to the beginning. Well, here's this tune. Okay, goes up, goes down, goes up, down a little, up a bit more, down a bit, up, down, up, 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 up. Lots more ups than downs because you can see it's increasing in height overall. That's an okay report. Here's the tunes that look like. Here's some easier tunes. This one stays more or less in a range. The real thing is you can't tell when you go up. You might be going up one step and down a bunch of, a very large interval. This just tells you kind of I guess, not even really a derivative. It's almost like the absolute value of the derivative or something. Derivative of the absolute value of the change, something like that. Maybe it's, I don't know. it's something anyway. But what I think we're seeing, I think what we're seeing is on these inputs. I don't think these are using p colon. That's probably worth checking. Nope. Okay, wrapped around. Okay, so this input file won't be very good for what we're about to do, but in a more general case, fiddle tunes do use parts. Let's go down to the examples. Okay, do we see any parts? Here's one. Okay, this one is AB2, AC2, A. All right, and here's the A part, the B part. Where's the C part? Okay. Well, I would have expected a P colon C, and here it is. Okay. So if we do this input file, we would see that our parsons code just runs through D, G, G, T, G, G, through all the notes. It doesn't take into account that this is really A and then B and then A and then B, which might give us a totally different sound than a tune that just did A and C only, say. Okay, so our existing parsons code doesn't handle this case correctly because it doesn't take into account that parts repeat. Okay, and so we would like to make this work for our existing parsons codes. And again, I think we'll need to take care of variant endings and who knows what else. But it's kind of time to make the real reflect the whole thing. Okay. Verse 1, verse 2. That's kind of like the parts, isn't it? But anyway, our parsons code parser works for very simplistic view of the notes. Just give me the notes in order. It doesn't take into account that parts repeat. Okay, and we need to take that into account. Okay, so I would say this is really just a continuation of the existing parsons code. Let's say more sophisticated. Let's say parsons code for tunes with parts. That's kind of what we're really trying to do. And so we will need to parse the parts P colon code in the tune header and then recognize the P colon code in the tune body. Okay, so that's where you tell what the part is. And we'll need to structure the tune representation to reflect parts. I think that's accurate. Okay. Well, we're kind of due for a break. So let's take a break and then we will deal with this, the P code in the tune header. So that was the AB2, all the parentheses, all that stuff. Think that's what we want. And it's going to get more complicated when we get down to this reflecting the parts thing. We'll have to do some work. All right. Let's take that break, maybe about 3 minutes, and we will come back and start tackling the tune header, make the tune understand what the parts are supposed to be, and then match up the parts in the body and make sure we represent this thing to reflect that. All right, so about 3 minutes. All right, welcome back. Okay, parse the P code. Let's see. We got our parser. I guess we probably ignore them for now. So let's go down to the main body of the thing. Find tunes. Okay, so what we're doing is we got this state variable tracking what we're looking for. So for now, we are looking for P as a possibility in the tune or the body. This comment is really not relevant now. So we're looking for content. We find the first X line and do it. Gather titles. Okay, so basically, let's make sure this is legit. Okay, tune header starts. Yeah, so P is a possible tune header. So all we're doing now is we recognize that a tune header started, but we ignore it. Okay. I don't know. Something is going. I don't want to say wrong exactly, but when I start growing this thing, it feels like something feels wrong. But right now, this is what we do. I mean, we're handling a line starting with K, puts us in the tune body. But if it's not, we're just going to track it. Okay, so I think what we're going to say is we need the tune. Long method. All right, tunes. Let's go there. Tunes is a sequence of tune. Okay. So here's a tune, and notice there's no concept of parts. So let's start there. So ABC parser tests. Okay. I don't know, this key stuff, maybe that belongs elsewhere. Maybe I'm back to saying I don't. I don't think this file is broken down enough. Okay. Extra characters, check tune parsing. Okay, that's a helper. Well, there's reference number parser. Okay, title parser. Let's see, parser has reference number parser, title parser. Do I need a part parser? Okay. So I think we're at the point of asking the tune itself. Okay. Well, maybe we should start with the defaults, I guess. What I'm going to say is expected. Okay. That's the contents of that parser. Okay. Well, let's check the parts parser. Parts parser. Oh, come on. This is interesting. Parser equals parser.parts parser. And we're saying if you well, what am I saying? I'm kind of saying if you don't specify one, it should just default to A. Okay, so it's not really a parts parser kind of thing. It's really a let's tune defaults to just a part. Okay, so I don't know. Do we have tune tests? Okay, I'm sorry. I keep getting these backup messages. Okay, tune defaults. So let's make a new tune. Let tune equal tune reference number 1. Okay. Tune.parts, which doesn't exist. Does it exist? Where did tune go? Let's get tune over here. Oops. Tune does not have parts. Okay. Cannot convert string to expected type int. Okay. I don't know if that's strictly required, but all right. Well, I want to say this is what the part should be is part I think I guess that's what we're defining, but it doesn't exist yet, but I'm saying if the tune should have parts and the parts should default to just an A part. Let's make this domain and let's make this test in here. Okay, so this is a new file. It's tune tests. And it should be in both sides. don't know why that's crazy. Okay. And then the test is this one. Whoops. Is this one. Okay. Tune reference 1, tune.parts should just be part A. Okay. Part is not in scope. All right. We're going to define it. Where's tune? I think I need tunes. Let's get this over here where we're working. Okay. Now the tune, I don't think it has a part either. Part. No. Okay. Let's define an enum. And case part, and it takes a string. I don't know if that should be character or string, but we'll say string. Okay, so that should make this part a little happier once it catches up. Okay, and then we'll need to say it's equatable. Part is equatable, and the default equatable stuff is fine, or should be. Okay. But there's no tune.parts, so let's give it that. Public var parts of part. Okay. And we need to initialize it. Okay. Junk. Part cannot be constructed because no accessible initializers. Part. Oh, dot part. Okay. Now that should fail. Where am I? Well, he should be in shared tests. Oh. Okay. Okay, part failed because Z is not equal to A. Okay, so let's fix this. Okay. All right, that's a start. Okay, now I think we are back to a parser test. Okay, because now we're not caring about the structure so much. All right, so let's test parts parser. Okay, and then what do I expect? Ooh, well, the parts parser, I guess, is going to produce parts. Check successful parse, the parser, and then the input is p:. Let's just put an A part in. Okay, and the result should be dot part A. Okay, so if you explicitly say it, you ought to get it. Yeah, that doesn't exist. equatable has no member part. Part. Okay. This assumes there is a parts parser, which we don't have yet. Okay. Var parts parser reads characters in and it produces a part. Okay, and it's part of our initialization that we promised to make one. Okay. And we'll need a method to do it. Okay, and it produces cbind of part. All right. And, well, let's just return some junk. We'll make parser.parse. Match p : match p. Let's just start there. Okay. Part is parser.parse. Okay, so I'm making a deliberately bad parser here, and oops. I think I have a way I can say I want to keep the thing on the right, and then do I have constant? I have to look. I don't remember what it's called. Inject. Okay. Parts parser, ABC parser. Let's inject a value which is part z. Okay. Or maybe just question mark for now. I'm purposely putting together a parser that always returns a question mark for a part, which we know is not really legit. Okay, and this make parts parser is called in the constructor here to build it. Okay, and we promised it would be built with the exclamation point, and then we built it in the constructor, and now it just handles the P without the P colon. Okay, and this ABC tests, put this here, ABC tests, we gave it the parts parser. Oh, that's kind of weird, isn't it? Let's make this called parts parser. Okay. Now, this should fail because we're looking for P. Where's check successful? Okay. Part question mark is not equal to part A, and there are errors. Sorry, there are characters left. We didn't parse colon A. All right. Let's make something happen here. Okay. So parts parser. It's more like this. It's got to match the colon. And then it's got to be a bit pickier. Okay, so it matches P colon, and then it matches range. Did I call it range? One of range. And that's a Z. I think that should be okay. Okay. And inject part question mark. So I think that should be a step closer. It should match the whole line, but not match the value. And one failure. Oops. Oh, there it is. Okay. The value question mark is not equal to A. Okay. So now, instead of inject, we're going to convert it, bar greater, and then the function is, we really just have that character, so let's make a string out of it. Well, let's return part of a string of $0. Okay, so take the character we got back and turn it into a string, and then part wants a string. So do that. I don't know. Maybe part could just be a letter, a character. But anyway, this should pass. We may be allowing more than we care to, but all right. Oh, that's a good step. All right. Now it's going to get complicated. All right. What do we want to do next? Let's go back up here. Parts. Where were they? Well, I think this said something about that. Right, parts. Okay. States the order they are played. Okay, so well, what would be simple? I could do A3, I could do AB. I think there's a sequence thing here going on, right? Like the sequence AB, AC, so on. Okay. I could put things in parentheses. I can use numbers, and I can ignore dots. Dots may be placed anywhere to increase legibility. Okay. I'm not gonna worry about the dots too much, but AB, like AABB, if you said that, that seems like a pretty normal thing to say. Let's deal with that. Okay, so I guess this is a parser test. Let's find P colon. Okay. It's kind of a, we're going to do multiple things test too. Okay. AB. So I think this should be a sequence. A sequence, and then in the sequence is part A and part B. Okay, we don't support sequence yet, so it's not surprising there's some complaints. Okay, so let's close this. That closed that, that's closing that. All right. So this should be a legal sequence, but we don't have the concept yet, so we got to add that to tune. Okay, so part could be a string. It could be a sequence of array of part, all right, which makes this an indirect enum. It's recursive, in other words. Okay. And let's see if that's enough to make us happy. Oops, parser tests. Good. All right, this should fail because nothing creates a sequence part yet. Okay, and then, well, we'll just double check, but part A is not equal to sequence part A, part B. Okay, and we haven't parsed everything. We still got a character left. Okay, the B presumably. All right, now I think what we're saying is this is a sequence of characters. It's one or more characters like that. Now, okay, this is well, let's see if this works. It's not going to work. I just don't know if it'll compile. I guess it will. Okay. It's not going to work because there's no sequence here, and we're saying it should produce a sequence. Okay, part AB. So it treated it as a string and put the parts in together. So our semantic parsing stuff is not sufficient here. So let's make a function that's going to do the work. Build parts, and it's going to, I don't know what it's going to produce yet. Well, I do. It's going to produce a part. Okay. And we're going to call it here. Private. Okay. And if you return, this thing is going to take, well, it's going to take parts is an array of string, I think. Maybe array of character. Okay, we're trying to match the type of one of. Okay, so and $0 is now parts. Okay, this should get me as far as I was before. Same failure. Let's see, is that on here? Yeah. AV parts with AV is not equal to sequence of parts. Okay, so this function needs to deal with it. So if parts dot count is 1, then we can just return part dot part of string of parts because there's only one character. Okay. So we'll just return that. Otherwise, we're going to return something else. Well, in this case, I'm doing it in small bytes. Okay. The thing we're not doing. Okay. So the first test passed, which is good. But the second test is failing because we're just returning the AB. Well, now we know it's more than one. We know we ought to return a sequence. So instead of this, what I want to do is let individual parts equal, I want to map each character parts dot map. What do I want to do for each character? Well, I want to do part dot part. I'll make a string out of it, $0. Okay, so I'm mapping each character to a part, and that tells me, and then here I just want to return the sequence of individual parts. Okay, because the sequence takes it takes an array of part. Okay, this should pass. All right, now I can move this up because notice that's sort of what I'm returning here. Okay, if the count is 1, then let's just return individual parts sub 0 because there's only one of them, and it's the part we're dealing with. Okay, now that should still pass. Okay, handle one letter or multiple letter part descriptions. All right, so the whole thing, all right, go back here. All right, so I've dealt with, I can do PAAA or PAB. That's fine. I'm enforcing that it's A through Z. That's fine. Let's see. So the dot seems, yet another thing they've introduced to just kind of like, I don't know. It doesn't seem more readable to me, but what do I know? I could have a part followed by a number. So I don't know. I feel like I'm getting, this is almost like expressions. Actually, years ago, I worked on a system that did overlays rather than virtual memory. And what you would do was describe how you wanted overlays. Well, you would do this kind of thing. You would put these together and say, oh, these are in the same overlay and these are in a different overlay. And this is all in the big body of things. These nested expressions like this. But I think what we're trying to say is it can be a letter or it can be a parenthesized thing, optionally followed by a number. Okay, let's get the parenthesized ones. A test. Okay, got to get my head straight here. We went 1 hour. We're at 1:30. Okay. We stop at 2:30. Okay, keep it straight. Take a break. These things happen. All right, ABC parser tests. Let's get down to okay. So now I want to make a parse. Well, I want to parse A, B. That's really the same as AB. Maybe we start simpler. Let's do A3. And I think this is becoming repeat part A 3 times. I think. Now, I don't know if I want to. I mean, we could push this concept out and make it record AAA. But I don't think we need to. Okay. So this says any parse followed by a number is a repeat parse. Okay, so let's define this. Repeat is a part followed by a count. Okay. Oh. Need a better word. Repeat. Count. Multiple. I can put it in the quotes. I don't know. Is that better? No, I'm going to change the name to multiple. Well, multiply. Okay. How about repeated? I think I can live with that. Okay, so this part is repeated n times. All right, our test should be legit now. Good, and it should fail. All right, and it should end up with leftover characters because we don't know what to do with the 3. Okay, we just found the A, like, okay, it's an A. Okay. And I don't know, I'm pushing off something. All right. So it's that, but then it's also it's this optionally followed by an optional number. Maybe we can do this. 1 of 0 ... 9. Okay, so match P colon and then A through Z this isn't optional. I almost want to make a little grammar. Probably should have done this sooner. Let's do it. This is the part grammar. Okay. And let's bother with bullets. All right. So I think what we're saying is kind of like a part goes to A through Z Or, well, we can do that by this, or it goes to a parenthesized part. This is really A to Z plus one or more, or it can be a parenthesized part. I don't know why that doesn't like that. Okay. Or it's a part followed by a number. No. That's a left recursive grammar, so it's not very good for recursive descent. Another way to do this would be to say this is digits goes to this repeated, and I can have this followed by digits or this followed by digits. Optional. Now the complaint I was getting is some other kind of problem. It's really a problem with the way this works. It sees this and it says, okay, this has got to be an array of A to Z, and it creates this and it says, oh, you're an optional array of A to Z, and that's not quite legit. Maybe I can parenthesize, because it's trying to blend them into one big array of A to Z. To that same problem. Requires the type character and many characters be equivalent. Requires the type satisfy character. Why is this character? I don't feel like the parentheses should really matter. But this is subtle. Okay, the type satisfy character and many characters be equivalent. See, I would have thought this would be optional. Let's try that. Requires the types character and optional be equivalent. It's really trying hard to map these together. Maybe it's my method. Because if build parts is wrong, it's not happy. So let's do this. Let's see what it says parser is. It's going to be horrible, but let's see. Okay, it's a tuple of a keep right, of a keep right, of a character, and many characters, and optional characters. Okay, so the first two characters are the P colon, and then many characters, and then an optional character. Well, this is really... Okay, so maybe that's okay. It's optional. This should be many characters is optional. Oh, really? Okay. So this now, it's an optional, it's a many characters and an optional many. Okay. And now I think we can make this right. Characters, this should become characters and character optional. Okay. This. Okay, character optional depart to nothing. Why is that? Maybe this is... Oh, one more friend. How about that one? Okay, so I'm saying this parts is now a pair. Let's just call it argument. Okay, and I'm going to say let parts ignore equal argument. Okay, so I'm just pulling out the first part, which is the characters we had before, and everything's building now. Okay, so I think we're still going to fail because we're totally ignoring that second argument on the repeat. Okay. If parts count equals 1. Okay. Yes, I think that's accurate. Well, I mean, I'm expecting failure, but I don't think I'm getting the right failure. Part A is not equal to repeated. Okay, we certainly don't produce a repeated, but I think my grammar's just not right. Okay, let's go back here. The problem is, I think I could say part equals A3B. That would be completely legit. So I think what I'm really saying is let's make a part 1 is letters part 1 is one letter followed by optional digits. Okay, and then parts is the sequence. This is really part 1 plus. Okay, I can have one or more parts which are letters followed by optional digits, or I can have parenthesized parts. Well, that almost makes me think this is a part 1 as well. Okay. It's, yeah, because I could say parenthesis AB, parenthesis CD. That should not be a problem. And each of those can be digits. Okay. That's not what our code says right now. So, I mean, changing the grammar should make the code, I mean, we need to change the code to correspond. Because I'm not allowing I'm not allowing A3B. because I said you'd have ABCs followed by digits, but the digits don't apply to all those in the sequence. They only apply to one. Okay, so a one part thing is legit that way. Okay, let's go back to our grammar. So A through Z, okay, so this, well, let's make this reflect it. Okay, so let part one equal its one letter followed by this. An optional list of digits. Okay, well, we can say digits too. So let digits equal this. Okay, and then this is optional digits. Okay, make it read a little more like the original. Okay, so that's a way to be legit. Okay, digits is that. Part one is a letter followed by optional digits. All right, and now I'm saying this is well, I could almost build parts. I mean, let's make a build part. I don't know. I'm going a little far. Its argument is this. No, its argument is a character and an optional array of characters. Okay, that's the digits. And it produces a part. Okay, the part it produces, well, that's let's let part and digits equal argument. So we're going to tear that apart. Now, if we just return part dot part of string of part, okay, we're ignoring digits for the moment. Okay, we're just trying to get back to where we were. All right, so if I had build part and I pipe that from here, pipe that to build part. Okay, so this is a part one, and I would like this to build a sequence of these. Okay, this is a sequence of part ones. I gotta have at least one. Okay, it says match my grammar. I want part one plus. We got a prefix plus on the other one. Okay, so one or more parts. Sorry, a part is one or more part ones. A part one is a character followed by optional digits. Okay, so optional this thing then, because each one is producing a part, build parts now should take an array of part. Okay, so this is array of part. And let's go back to calling it parts. Okay. We don't need to do this mapping anymore because they are parts. We don't need to split apart because that's no longer an issue. All right, if parts count is 1, return parts sub 0. Otherwise, we're going to make a sequence out of those parts. Okay, so this is the sequence mechanism. All right, this should pass our original test and fail the new one still. Okay, because we're not doing anything with the digits, repeated digits yet. Okay, but now that's where this, we've isolated it to here. Okay, so I'm feeling good about this. All right, so if digits.count is 0, no, if digits is nil, then we just return what we did before because we just sort of assumed the case where digits was nil. Now we need to return the right thing. So we're going to return repeated with the argument and character to expected argument type part. Oh yeah, we do want part. Part of string of part. That's a lot of parts. Okay. Convert the part piece into its name and store that in the part. Okay, I'm feeling like these characters would be a better place to put in there than to put in there. Okay, but that is that, and now we need to convert the number to that, and number is digits is going to be an array if we exclamation point. So I think we can do int from the given text. Yeah. Okay, so int of digits bang. Oh. No exact match. Oh, I have to say text. Text digits. All right, is an array of characters. And no, he doesn't like that. Is it string? Digits. Being more text-like. Remove text. Okay. Value of optional type int. Well, I'm going to say it's 1. Okay. If we can't identify the string convert the string of digits, we'll just say it's 1. I think because the way we constructed it, we know it really is digits. It is multiple digits, 0 through 9. So it should be okay. All right. So now we have the repeated here. Let's see if this works. Should. It's a 1 level repeated. All right. Yeah, so handle repeated parts. Number associated with a letter named parse. Okay. All right, I think we're due for another little break here. We got 2 of the major cases done. We haven't dealt with this one yet. That the fact that it could just be well, it could be another kind of part with the digits there as well. Okay. So take about a 3-minute break and we'll come back and tackle those parenthesized ones. And I think we're closing in. We don't do the dots yet. We can work on that, but we're getting there. All right, welcome back. Okay, so we've got, let's see, we dealt with the 1. Down to our parts. Okay. Compare this. So A3, theoretically, we've got that one working. This one we don't have working. So let's worry about that one. Well, let's be complicated. B2, P3, AB2, 3. Okay, so this should be a repeated something. Repeated 3 times. Well, what's the something? Well, it's a part dot sequence of array part of A and a repeated part A with a repeated part B 2. Okay, let's get the nesting right. Okay, so this is a repeated with a sequence inside, and I guess that can go up here. This comes down. A sequence which is part A and repeated part B 2. Okay, that closes the repeated, closes the array, closes the sequence. Okay, I think this will fail. Okay. And failure to expected character in A through Z. Okay, yeah. We don't allow parentheses yet. Okay. And I think I want to change my grammar again. My goodness. Do I? Right. So what I'm saying I want to change it to is this, that, or something. Well, that something is this. Like that. Now, this is where it's a little tricky. Ah, boy. Okay. The problem is this part, well, we're calling parts parser equals this, but we want to reference it in here in part 1. Hmm. Now, I know we've done this before. I don't know if we've done it in this app, though. I don't really think we have. Oh, maybe we have, because Grace notes. Character notes, note line parser. Let's pull up in a previous project. I don't remember what this is. Expressions. Oh, that was an example. Let's take basic. I'm not sure which branch we're in, but okay. See if we can tell from here. Strategy. Okay, so this uses this parser combinator approach, and expressions, let's see. Yeah, expressions can be built from expressions. So unary expression includes expression. And so we have to be careful when we build the parser for this. Okay, so I think parse is just the sort of the noun parse. Syntax analyzer. An expression parser. We do a make expression parser. Okay, let's go look at that. Right, we build the expression parser first, then we can reference it. Okay, so we'll take something kind of like this, and our parts parser. Well, we'll say let parser equals bind. In our case, it's cbind of part. Okay, so we're saying let's make a parser that is going to convert characters to parts. Now here, well, let's let result well, let's say parts parser equals that, and then we have to bind the expression parser back at the end. The return. Okay, yeah, we have to do a bind onto this new parser. Okay. Parts parser dot bind to parser dot parse. Okay. And whoops, and then I think we just return that. Yep. Return parts parser. Okay. So we declare the recursive method parts parser. We build a parser that corresponds to it. Oh, this is not quite right, is it? Okay, so parts parser, I just want it to be the part that deals with the C1 parts. Okay. Jeez. I don't know if I'm going off on too long of a tangent again. All right, but I have this parts parser. I want it to be the part that matches this much. Okay, and so I say part 1 is that. I have to bind it in. Well, let's say I think we're going to return parser because it's the big. Let's make this the full parts. No, let's just call it parser. Okay, we're binding. We definitely want parser. Okay, but I want to make parts parser. Part is so being overloaded here. It's not the part. It's something else. Part description. Part spec. That's the thing that's going to be plus part 1 pipe to build parts. Okay, and then this can reference that part spec, and then part spec dot bind. No, part spec dot bind. I'm messing this up. Okay, first we say parts parser. Okay, this is part spec. Okay, a part spec parser is cbind of this. Okay, then I'm going to build up part spec. I'm going to move. Well, that grabbed quite so much. I want to move this up. Okay, so part spec parser dot bind to part spec dot parse. Okay, because this is the recursive part. I want part spec to be the recursive thing. I've got part 1 that's 1 A to Z plus a digit, and it calls build part, so it makes one part out of it. And part spec builds the whole thing, so that's the thing we're trying to get to. And then this should be, I think he's part spec parser at this point, and then we're just returning parser. Okay, that should pass all the old tests, but still fail the other. Cannot convert return type. That's really weird. So my return expression is type keep right, character part. So keep right of character is this second character. Keep right of character cbind to part. Cannot convert to cbind to part. That should be fine. Let's see what his type is. Should be cbind apart. Okay, so part spec parser. Okay, so part spec parser is cbind apart. You build it, you bind it here to something that's cbind apart. Well, and the outermost is pipe to part, so it should be a part. That should be okay. Should I put part spec in here? Probably should look at this one again. Okay, so expression not bind. Then we return that. And its type is massive. Expression parser is bind token to expression. And then I can use that parser in other places. Okay, what's going on here? Well, it seems still unhappy. Let's put this back to part spec parser, and I'm just gonna rebuild just sometimes this stuff is a little off. Okay, let's see the type of parser. It's keep right, character, bind apart. So this thing should be a bind character apart. I mean, keep right of character. Let's make sure everything's doing okay. So keep right of character, satisfy character should give me a satisfy of character. Keep right of satisfy character with bind character apart should be a bind character part, which is the same as bind character part. Okay. Build part. Part 1 should produce a part. Part spec should produce a part. This is the part I hate about these combinators. It just gets very hard to track between them. Okay, so part spec parser. This should be kind of a neutral change. It's not turning out that way. Part spec parser says, I'm going to create a parser that goes from characters to parts. And it doesn't have a parser function yet, but we produce part spec and bind its function in, and its function part part spec parser should be character to part. Okay, so it's character bind, it's binding character to part. This function should be compatible with that, and apparently is, because it's not complaining about this line. It's only here. I mean, if I said return part spec parser, what would happen? I mean, it would fail, but why is that acceptable? More tests should fail. All our part parser tests should fail because they don't. It's not looking for the p colon anymore. Okay, back here. So I've got my part spec parser. And why isn't it complaining that parser isn't used? Something's really funny. Right, I should get a warning here that parser is unmentioned again. Okay, but parser's type is cbind apart. Let's try and create a result equals cbind of part nothing, and then result.bind parser.parse. Return result. Build that. Okay, so all I did was I wrapped another layer around it of kind of anonymous parsing. So what I'm doing is I'm saying I've got this complicated parser, and then keep right, and then keep right, blah, 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 cbind part. And I'm saying, let's make a neutral one that's just, we just say it's cbind apart. It doesn't explain how it gets there. And bind in result to that parser that we know is really just boils down to a cbind apart, and return that. Okay. Let's see what this, again, it should pass mostly and just fail the current one because we haven't done anything with the parentheses yet. Okay. And we got like 5 minutes, so let's see what happens. I think this should do something with the parentheses. Okay, so what I've said is this should be build part. Well, we can refactor later. Let's try this, or match a left parenthesis, and we'll ignore the parenthesis because we don't care about them too much, followed by a part spec parser. I hope it accepts this. Followed by a right parend, and let's pipe that to build sequence. I'll just parenthesize this the same way. Okay, so we need a build sequence that's more or less like we have. Okay, build sequence. Well, is that a sequence? Yeah, I guess that's what it is. It's a sequence. It's a little different, but okay. So the sequence, this thing now gets a part spec parser, which is cbind apart. Okay, so it's giving us a part. Oh, I don't think I need to do anything here then. this thing already gives us a part. This gives us a part, so I think this is redundant. Okay, and this is not needed either. Okay. So if it matches this stuff, it's fine. If it doesn't, it matches a left parend, calls build part spec recursively, and then matches a right parend. Well, build part spec parser is supposed to return parts. So the left branch returns parts and the right branch returns parts. So it should be compatible and return parts throughout. And I maybe my assertion maybe what's wrong here. Oh, well, this part failed. One character at the end. What's this one? Okay. Sequence of TuneSim part A, B repeated twice. Oh, yeah, I didn't deal with the count. Okay. All right. Well, that gives us somewhere to start next time then, I think. I only parsed this, but I didn't do a digits parse. Okay. And so I think that's kind of what I was saying was I should be moving this inside here if this works in our remaining minute. And then that whole thing should be followed by digits. So let's put this piece inside. Okay, followed by digits. Cannot convert type to. Okay. I think I will undo this. And we'll let this be the failure we have. Okay. Not doing that. All right. So we'll pick up there tomorrow. Tomorrow's Wednesday. The time will be Eastern time, 1 to 3:30 p.m. or UTC 6 to 8:30 p.m. And I believe we're close on this, but got a little twiddling around to make everything compatible. But I think we can finish that part, add the dots, which we're ignoring, and go from there. I think that will just about do it. But we've made progress on this thing. We have a structure that can hold sequences of parts, repeated parts, or individual parts. I want to convert that to character. Let me put a note in here on that. Okay, I think that will probably simplify some things for us. And that should be usable from there. So thanks for joining, and I hope I catch you tomorrow or in the future. Take care. Bye-bye.